mole fraction is a percent composition, but not of a compound, as I did earlier, of a mixture of some kind. And in this case, it's going to be a mixture of gases. This is the symbol for mole fraction. Here is a 1 just to distinguish which it is I'm taking the mole fraction of. Normally, if it was, for example, oxygen, I would put this symbol and then a little O2 in the bottom corner and then an NO2. But since I don't know what I'm going to be taking the mole fraction of, I just put it as 1. So it is the moles of some particular thing over the total moles of all of, in this case normally it's going to be gases, of all the gases put together. So it's a percent. It is the percent of the total mixture. And it can also be written as this N1 over N1 plus N2 plus N3 for however many gases there are. What's going to be useful about the mole fraction is I can make this relationship. So I can convert this into a pressure and then that will help me in dealing with Dalton's law of partial pressures. So I've written it out in terms of moles, the ideal gas law. Now what I'm going to do is pull out this P. So P times V over R T. Now I'm going to make the substitution into the mole fractions. So N1 is now going to be P1 V over RT. Now I'm not going to distinguish V1 and T1 because these are going to be in the same container, so they will not have unique volumes and temperatures. They will all be the same. Then I'll have P1 V for RT, P2 V over RT, and P3. To say there are 3 for simplicity. Now all of these have a common factor up, above, and below, so these will cancel out. So the mole fraction of something is going to be equal to its partial pressure over the total pressure. So that means the total pressure multiplied by the mole fraction of something is equal to its partial pressure. So this is going to be something that is going to be useful to me when dealing with Dalton's law. For example, if I know the total pressure and I know the partial pressure, for example, if I have 3 gases, let's say, I don't know, let's make up some numbers. Say the first one has a partial pressure of a mole fraction of 0.7. Second one has a mole fraction of 0.2. Last one is 0.1. And I know the total pressure. And for simplicity's sake, say it's 10 atmospheres. And I want to know the individual partial pressures. All I have to do is just multiply the mole fraction times the total. So in this case it would be P1 would be 10 times 0.7, which is 7 atmospheres. B2 would be 2 atmospheres. It's a ridiculously easy one, but general idea. And obviously the problems will be more complicated, but this is the general idea. I should be able to think of partial pressures, Dalton's regular partial pressures, and then this form interchangeably, and that will be very useful to me. And honestly, it's not even necessary. I can think of it in Dalton's form and then convert it in the end, but whatever. It's not very, it's completely obvious, really. Didn't really need to do this, but there I have it.